Hello everyone. Today I am going to give some examples related to polar graphing. So in the previous video of polar graphing, I have explained you how to draw the graph of polar curve. Let's suppose you are given a r, a function of theta. So we know that the steps, first we identify the symmetries. Symmetries about x-axis, about y-axis and about pole. So we check all these symmetries. Corresponding to this symmetry, we will get the value of theta, and then corresponding to these theta, we will find out the value of r. Then we consider the pole and initial ray. We take a turn and cover the distance r, and by free hand we join all these points. We will draw the graph of the following function. So now just see an example. Let's suppose we have to draw the graph of r is equal to 1 minus sine theta. So first of all we check the symmetry. So check the symmetry about x-axis. X-axis means theta is equal to 0 degree line. So let's suppose this is initial ray and this is your pole and this is initial ray. Let's suppose P is any point having the coordinates r and theta. If the point P dash satisfy the graph, then we will say our graph is symmetrical about x-axis. Now what are the coordinates of P dash? We can reach at P dash by moving an angle minus theta because clockwise, and by covering the distance r. The another way to reach at this point is we can take a turn 2 pi minus theta and we can cover the distance r, then we can reach at the point P dash. The another two ways are with the help of backward distance. So we can take a turn this angle is pi minus theta. We have our direction towards this line, but if we want to reach at point P dash, we have to come back. So that backward distance is denoted by minus of r and the angle is pi minus theta. The same way clockwise we can take a turn this much. This is pi plus theta. Since it is clockwise, so we will take it as negative and then minus of r. So these are four different representation of a single point P dash along this one complete revolution. So a complete turn mein these are all the four distinct representations. If one of them satisfying the graph then the graph is symmetrical about x-axis, otherwise not. So first of all we put this point. So we consider r comma minus theta. We replace r with r. This is our left hand side. We replace theta with minus of theta. So this will become 1 plus sine theta, which is not equal to r. So left hand side is not equal to right hand side. So this point does not satisfy the graph. Now we consider the next point r and pi minus 2 pi minus theta. So when we put theta instead of 2 pi minus theta instead of theta, what will we have? This is 1 minus sine 2 pi minus theta. In the fourth quadrant our sign is negative, so this will become 1 plus sine theta. Again this is not equal to r. So this point does not satisfy the graph, this does not satisfy the graph. Now substitute this one. So replace r with minus r and theta with pi minus theta. So this is 1 minus sine theta, which is r. Now again these left hand side is not equal to right hand side, so this point does not satisfy the graph. The same way this one, when you replace r with minus r and theta with 1 minus of pi minus of theta, you will get this is 1 plus sine theta, which is not equal to minus r. So this, if you take minus to be common, you will get here it will be 1 plus sine pi plus theta. Pi plus theta again give you minus sine, so this will become 1 minus sine theta. So this is r, this is minus r, again it does not satisfy. So all these four representation of a point P dash does not satisfy the graph. So this implies the graph is not symmetrical. About x-axis. Now we will check the symmetry about y-axis. So y-axis means theta is equal to pi by 2 degree line. This is our pole, this is the initial ray, this is any point P having the coordinates r and theta. This is our y-axis or pi by 2 line. So if the point P dash, this satisfy the graph, then our graph is symmetrical about this y-axis line or theta is equal to pi by 2 line. Now since angle this is theta, so this will become pi minus theta. So the coordinates are r comma pi minus theta, or we can take a minus theta. Our direction is toward this line. If we want to reach at P dash, we have to come back. So this is minus r comma minus theta. So if we substitute the point r comma pi minus theta in 1 minus sine this is again 1 minus sine theta, which is r. So this point satisfy the graph. This implies the graph is symmetrical about y-axis. But since our graph is not symmetrical about x-axis, so clearly it is not symmetrical about pole, right? Now since our graph is symmetrical about y-axis, so it is sufficient to consider theta to be minus pi by 2 to plus pi by 2. Rest will be drawn with the help of symmetry. So we consider theta to be minus 90 to plus 90. So when you take theta to be minus 90, the value of r will be what? It will be 1 minus sine of minus 90, which will become 1 plus 1, 2. At minus 60 degree, it will become 1 plus square root of 3 by 2, which is 1.73 by 2 is 0.8. So that will be 1.8 approx. At minus 45, it will be 1.7 approx. At minus 30, it will become 1.5. At 0, it will become 1. At 30, it will become 0.5. At 60, it will become 0.2. And at 90, it will become 0. So these are the corresponding values of r corresponding to these thetas. So now we take initial ray, we take a pole, we take initial ray. Now we draw the take the turns. Now at 0 the distance is 1. So if we move angle 30, the distance is 0.5. If we move an angle 45 or 60 degree, the distance is approx 0.2. At 90, the distance is 0, right? So if you take a turn minus 90 degree, the distance is minus 2. If you take a turn minus 30, the distance is 1.5. At 45, minus 45, it is 1.7. At 60, minus 60, it is 1.8. And then it is 2. So I draw with the help of this. So at this is 1, this is 0.5, this is 0, this is 1.5, this is 1.7, 1.8 approx, and then this is 2. So if you draw this with the free hand, you get the graph of r is equal to 1 minus sine theta. Now since our graph is symmetrical about y-axis, so rest will be drawn with the help of symmetry. So what will be the graph of r is equal to 1 minus sine theta? So this is said to be the cardioid. So this is cardioid. R is equal to 1 minus sine theta, which is symmetrical about y-axis and which is 0 at 90 degree. At minus 90 degree, it is 2, right? So this is the graph of r is equal to 1 minus sine theta. Now just see one more example, and let's suppose we have to draw the graph of r is equal to um, r square is equal to sine 2 theta. Again, first of all, we check the symmetries. So we will check the symmetry about x-axis. So this is your initial ray, this is pole, this is any point P having the coordinates r and theta. If the point P dash satisfy the graph, then our graph is symmetrical about x-axis. Now what are the coordinates? This is angle minus theta. Another way to reach at this point is r comma 2 pi minus theta. In form of backward distance, the way is pi minus theta with minus of r and minus of r minus of pi plus theta. So if we substitute the first one, it does not satisfy in the graph, because when you replace r with r and theta with minus theta, it will become r square is equal to minus sine 2 theta. Not satisfying. When you substitute r to be r and theta to be 2 pi minus theta, you will get r square is equal to sine of 2 times 2 pi minus theta, which is sine of 4 pi minus 2 theta, which is minus of sine 2 theta. Again not satisfying. Similarly, when you substitute, replace r with minus r and theta with pi minus theta, again this is r square is equal to minus sine 2 theta. So not satisfying. So when you substitute, replace r with minus r and theta with minus of pi plus theta, again it is not same, it is minus sine square to sine 2 theta. So not satisfying. So all these 4 points, distinct representation of the point P dash, not satisfying this r square is equal to sine 2 theta. So the graph is not symmetrical about x-axis. Similarly, when we check the symmetry about y-axis, again the graph does not satisfying the representations of this point r comma pi minus theta and minus r comma minus theta. So when you substitute minus r comma minus theta, it is not satisfying. When you replace r with r and theta with pi minus theta, it is again not satisfying. So the graph is not symmetrical about y-axis. So the graph is not symmetrical about x-axis, as well as not symmetrical about x-axis as well as y-axis. So now we need to check along the symmetry about the pole. So symmetry about pole means if you are having any point with coordinates r and theta, if this point P dash, they satisfy the graph, then your graph is symmetrical about pole. Now what are the coordinates of P dash? You can take a turn this much, this is pi plus theta, and then you can reach at this point. So this is r pi plus theta, or another way you can move theta angle and back distance, so minus r comma theta. So when you substitute this point in r square is equal to sine 2 theta, you replace with r with minus r, you get r square. You replace theta with theta, you get sine 2 theta. So these two are equal, your left hand side is same as that right hand side. So this point satisfy the graph. So this implies your graph is symmetrical about, it is symmetrical about pole, right? So we have to consider either angle moving from 0 to pi or minus pi by 2 to plus pi by 2. Since we have only one symmetry and the symmetry is about pole, so either it is sufficient to consider theta from here to here or from here to here, right? Now next, what we observe, since r square is equal to sine 2 theta, it means our r is plus minus square root of sine 2 theta. So we have to consider those theta such that this should be positive. Since sine 2 theta is positive, sine 2 theta, this is positive in the first quadrant, right? And in the third quadrant, because here we are having 2 theta. So it is sufficient to take theta from 0 to pi by 2. Rest will be drawn with the help of symmetry as well as periodicity, since the graph is periodic with period pi. So after pi it will repeat again. So it is sufficient to consider theta from 0 to pi by 2. So now you choose theta from 0 to pi by 2. Now just see what is the value of r. When you take theta to 0, your r will be 0, r square is 0 and r is 0. When you choose theta to be 15 degree, you get r square will be sine 30 degree. Sine 30 degree is half, which is 0.5. So this is plus minus square root of 0.5. At 30 degree, the angle is sine 60. At sine 60, the value is root 3 by 2, which is 1.73 by 2, which is 0.8 approx. So this is plus minus square root of 0.8. At 45 degree, it will become 90 degree. Sine 90 is 1. So this is plus minus 1. At 60, it will become sine 120, which is again root 3 by 2. So that will be 0.8. So plus minus square root of 0.8. At 90, it will become 0. So this is 0. So now you draw the graph. This is your pole. This is the initial ray. At 0, the distance, when your angle is 0, distance is also 0. Right? When your theta is 15 degree, your distance is plus of square root of 0.5, which is very small, and minus will be denoted by back distance. So this one. At 30 degree, the distance is square root of plus minus 0.8. Let's suppose this. Back distance is also plus minus 0.8. At 45, the distance is 1, and the back distance is also 1. Right? Then at 60 degree, again it will become square root of plus minus 0.8, which is same as that at 30. Then at 90 degree, it will become 0. So if you join all these points, it will become a leaf. So now, since your graph is symmetrical about pole, so you get this leaf. So this is the graph of r square is equal to sine 2 theta. Since the graph is not symmetrical about x-axis as well as y-axis, so we will have only these two leaves, since the graph is symmetrical about pole only. Okay, so this is the graph of r square is equal to sine 2 theta. Now see what more examples. R is equal to 1 plus cos theta. If you will check the symmetry, it is symmetrical about x-axis only. And if you consider since it is symmetrical about x-axis only, so you have to consider thetas varying from 0 to pi. So if you draw the graph of this, you will get at 0 it is 2, at 30 it will become 1 plus square root of 3 by 2, which is 0.8. 1.8, this is approx 1.7, this is 1.5. At 90 it will become 1, at 120 it will become 0.5, and 180 it will become 0. So if you draw the graph of r1 plus 1 plus cos theta, you will get it. This is so at 0 the distance is 2, at 30 degree the distance is 1.8, at 45 the distance is 1.7, right? At 60 degree the distance is 1.5, at 90 degree the distance is 1, 120 it is 0.5, and at 80 it is 0. So if you draw the graph, you will get this. Now since our graph is symmetrical about x-axis, so this is the graph of r is equal to 1 plus cos theta, which is symmetrical about x-axis only. So this way you can remember the graph. This is cardioid shape. This is r is equal to 1 plus cos theta. Similarly, you can draw the graph of r is equal to 1 minus cos theta. This is the reverse of this. Since the graph is symmetrical about x-axis only, and at pi it will become 2, and at 0 it will become 0. So this is the graph of r is equal to 1 minus cos theta. Similarly, the graph of r is equal to 1 plus sine theta and r is equal to 1 minus sine theta. Both these are symmetrical about only y-axis. So the graph will be at 1 plus sine theta, it will become this one. At 1 minus sine theta, at minus 90 by 90 degree, it will become 2. So this is the graph of r is equal to 1 minus sine theta. And r square is equal to sine 2 theta. So the graph is symmetrical about pole only, and the graph it is 1 at 45. So this is the graph of r square is equal to sine 2 theta. Similarly, the graph of r square is equal to cos 2 theta, that is also symmetrical about pole, that will be at 0 it is 1, right? At pi by at pi it will become negative, so the negative distance will be with the help of backward distance, right? So it the graph for r square is equal to cos 2 theta, it will be this one, right? So if you check the symmetries, it is symmetrical to. Now see how, if you consider r this angle p having the coordinates r and theta, so the coordinate of p dash it will be r minus theta. This satisfy the graph. If you consider here, it's minus theta and minus r. This satisfy the graph. So since your graph is symmetrical about x-axis as well as y-axis, so it is symmetrical about pole also. So the graph for r square is equal to cos 2 theta will be this one. Similarly, you can draw the graph of r is equal to cos 2 theta, or r is equal to sine 2 theta. This graph is symmetrical about all the axes. It is symmetrical about x-axis. Now see by which point it is symmetrical about x-axis. It is symmetrical about x-axis by the point r is equal to minus theta. It is symmetrical about y-axis by the point, you can move this angle, this is pi minus theta, and r or minus r minus theta. Now just see this point satisfy the graph. When you replace theta with pi minus theta, you will get 2 pi minus 2 theta. So that is cos 2 theta. So r is equal to cos. So this satisfy the graph. This satisfy the graph. So since your graph is symmetrical about x-axis as well as y-axis, it is sufficient to have theta varying from 0 to pi by 2. So consider theta from 0 to pi by 2. You can draw the graph of r is equal to cos 2 theta. At 0 the value is 1, at 30 it will become 0.5, at 45 it will become 0, at 60 it will become 120, so which is minus 0.5, and then at 90 it will become 180, which is minus 1. So if you draw the graph, since it is symmetrical to all the axes, so if you draw the graph of r is equal to cos 2 theta, what will you have? At 45 it will become 0, at 0 it is 1, then 0.5, then 0. So you have this leaf. At 60 degree back distance, so you will have this leaf. Now since your graph is symmetrical about x-axis, so you will get this. Right? At 90 degree you will get, you move the angle 90 degree and you get minus, so you get this leaf. Now since your graph is symmetrical about y-axis, so you get this leaf. Symmetrical about pole, so you get this leaf. So the graph for r is equal to cos 2 theta will be the 4-leaved rows. Similarly, the graph of r is equal to sine 2 theta, it is the 4-leaved rows, but around the angle 45. At 45 it is 1. So this is 4-leaved rows, this one. So this is the graph of r is equal to sine 2 theta. Similarly, you draw the graph of r is equal to half plus cos theta. When you check the symmetries, it is symmetrical about x-axis only by the point r and minus theta. So this point satisfy the graph, so this is symmetrical about x-axis. It is not symmetrical about y-axis, not symmetrical about pole, so you have to consider theta to be 0 to pi. At 0 it is 3.5, half plus 1, sorry 1.5. At 30 degree it will become half plus 0.5 plus point prox 8, then 0.5 plus 0.5, then 90 degree 0.5, then 120 degree. At 120 it will become 0, and at 180 it is minus 0.5. So now you draw the graph. So this is your x-axis. At 0 the distance is 1.5. At 30 degree it is 1.3 prox. At 60 degree it is 1. At 90 it is 0.5. At 120 it will become 0, and at 180 it is minus point, so back distance. So it means if you consider theta to be 150, it is again at 150 back distance negative, some negative. So if you draw all these points with free hand, what will you get? You get at 120 it will become 0, then back distance at 180 it is 0.5. So you get some inner loop. Now since your graph is symmetrical about x-axis, so you get some inner loop over here. So this is the graph of r is equal to half plus cos theta. So these are called lemma cones, some lemma cone with some inner loop, right? Similarly, you draw the graph of r is equal to 1 plus 2 sine theta. This will be symmetrical about y-axis only by the point r comma pi minus theta. This satisfies the graph. Since this graph is symmetrical about only y-axis, so we have to consider theta from minus 90 to plus 90. So if you consider theta to be minus 90, minus 60, minus 45, then minus 30, then 0, then 30, 45, 60, 90. So at minus 90 it will become 1, minus 2, minus 1. At minus 60 it will become 1 plus minus 2 into 1 by 2. So 1 minus 1, 0. At minus 45 it will become 1 minus 2 upon square root of 2. So 1 minus 1.4 1 minus 1 point minus 30 it will become 1 minus, sorry, at 60 it will become 2 into square root of 3 by 2. So not 0, it will become 1 minus 1.73. So that will be become minus 0.7 something. Here you have minus 0.1.44 something. So at 30 you get 0, at 0 you get 1, at 30 you will have 1 plus 1, 2. At 45 degree you will get 1 plus 1.4 which is 2.4. At 60 you get 2.7. At 90 you get 3, right? So if you draw the graph, consider the initial ray, right? Since your graph is symmetrical about y-axis, so we have to draw the graph over this side. Rest will be drawn with the help of symmetry. So at 90 degree the distance is 3. At 0 the distance is 1. At 30 degree, 45, at 60 degree. At 30 the distance is 2, then 2.4, then 2.7, and then 3, right? And at minus 30 it is 0, then minus 45 it is minus 0.4, then minus 60 it is minus 0.7, at 90 it is minus 0.1. So 0 at 0 it is 1, right? And this side at 30 it will become 0, and then at 45 it's going back. So this, so again you have some inner loop. So now since your graph is symmetrical about y-axis, so this inner loop, then this small. So this is the graph of r is equal to 1 plus 2 sine theta. So in this way we draw the polar graph. We first check the symmetries, then as per symmetries we will consider the values of theta and corresponding values of r. Then we take a turn, cover the distance, join with the free hand, we get the polar graph. We can also check the slope of the polar graph, that the graph has the curvy nature or has a peak. So we can find out the slope. So let's suppose you are given r is equal to f theta. Since we know that the slope, the tangent, it is given by dy by dx. Here x is r cos theta and y is r sin theta. So we can find out the value of dy by dx in the terms of theta. Now since r is a function of theta, further theta they are the functions of x and y, so you can apply the chain rule. So you can write dy by dx as dy by d theta and dx by d theta. Now what is dy by d theta? dy by d theta is what? Your r is a function of theta, so you can substitute r to be here f theta. So what will be dy by d theta? F theta as it is, the derivative of sine theta it is cos theta, then this as it is, sine theta as it is, and the derivative of f theta which is f dash theta. So this is dy by d theta. Similarly find dx by d theta, f theta as it is into the derivative of cos theta which is minus of sine theta, then derivative of f theta and cos theta as it is. So this is the value of dx by d theta. So now you can substitute over here. This is f theta cos theta plus f dash theta sine theta upon f dash theta cos theta minus f theta sine theta. So with the help of this we can check the slope. If the numerator part is 0, it means dy by dx is 0. So if we put this to be 0, we can find out those values of theta where the tangent is parallel to x-axis. If the denominator is 0, it means our slope is infinity, right? It means we can find those values of theta at which the graph is having the tangent which is having the vertical tangent and parallel to y-axis. So if the denominator is 0, we have the slope infinity, means we get those points of theta where the tangent is vertical tangent and it is parallel to y-axis. So we can find out those points where this dy by dx is not defined, it is 0 by 0 form. At those, these are those values of theta where the graph is not curvy, it is having some peak, right? It means the theta is not defined there. So here it is of the form 0 by 0. So we can find those points where numerator is 0 as well as denominator is 0. So at those points the graph is not curvy in nature, it is having some peak. So with the help of slope we can find the nature of the curve, whether the graph is having the curvy surface or a peak surface.